Welcome everyone, this is Zanta with Reaper Products. Today's video is on a request for how to create a street lamp post in Revit. Here I am in Revit 2024, and I'm going to go down the road of just picking a street lamp post and just designing it from scratch. I went over to Google and just did a general search for street lamp posts, and there's so many that's out there, so I'm not sure exactly which design the end user is requesting from YouTube comments. So I just kind of picked one right off the bat. Things to think about before you choose a specific lamp post. Some of them are going to be simple like this, which we're going to keep just for the sake of keeping the video short, where you have a single light source and then you have the structure and the housing. Other light lamp posts are going to be very antique-like, where they may have multiple light sources and then its base structure. And then there may be some where they're extended like this for like the highway, where they have two arms and they have two light sources. So if you're dealing with building a family of this nature that requires more than one light source, then the way to approach it is to create a host family, which is the structural part of it, all the the vertical members and the angled members and things like that, and then host in um, nest inside to light source individual families and place them where you need them to be and lock them in position. With a family like this, you can just start with a single light fixture family and build the housing and either save that as an individual family and then build this housing, this vertical structure as another family, and then nest this light source family into the host family that is the structure. And the reason you may want to do that is because you might want to create different housing designs and then use family types parameter to swap out in the host family. Again, for the sake of this video, to keep it simple, since I'm not sure, I wasn't given any parameters whatsoever as to how the street lamp post design is going to be or anything like that. I'm just going to pick something simple to teach the foundational stuff of how to build a family. So this is what we're working with. I went over to the website and this is all I've got to work with. And that's okay. So what we need to do is we need to start with a light fixture family in Revit. We need to understand the light source and its position relative to the level, and then placement of the height, if so we want to make it adjustable, and then deal with the housing and then deal with the structure. So that's the goal. So back in Revit 2024, I'm going to click New here under Families. It'll take me to the English Imperial subfolder of where the software was installed. And just to note, 23 and 24 Revit, when you install it by default, the library does not come installed. You have to download that separately and install that separately. So we'll scroll down, head over to light fixtures, and there's a lot of them to work with if you look carefully. You have light fixtures ceiling-based, wall-based, the generic one, a linear light fixture ceiling-based. So these three here are new in 2024. For what we need, we're just going to work with the general light fixture family. We'll click Open, and it'll build us a new family. We're going to save this as a family, and we will place it where we need, and we'll just call it Street Lamp Post Family, and hit Save. Now I'm going to type SD to go into shaded mode so you can see what it looks like, and we'll shift over to 3D and shaded as well. And because we're in 3D mode, we can't really see like the level plane of its position. So if we go to the front elevation and go to shaded mode, we can get an idea of the light source and its reference planes. So this reference plane says light source axis left, right. This one says light source elevation, and they're both locked. And if you look carefully, it says define origins in the properties panel, which I'll expand a little bit. And again, verifying this one as well. So where you see two reference planes that say define origins is checked, where they intersect is the insertion point of the family. So depending on how you're building this family and where you want the base point to be, the insertion point to be when you're loading it into a project, you may want to make it the bottom here where you have a reference level. So typically what I'll do is I will take this level datum and move it out of the way because a lot of times if you notice, you'll have a level right here underneath and it's hidden. And you can call this whatever you want. So we're going to call it RL just for reference level plane. And then what I can do is I can select this horizontal reference plane that says light source elevation, uncheck define origins, then check this one, select it, and make this the check mark. That way my insertion point is down here. And then also when you're dealing with reference planes and modeling them and creating your model, a lot of times you want to have the reference planes kind of line up properly. So that's the first, is making sure your insertion point is exactly where you want. Secondly is the height of the light source. Where do you want it to sit for the lamp post? If we switch back over to Chrome and look at this, a typical street lamp post of this height is probably in the realm of 12 feet. I don't know, I'm just guessing. So we'll kind of start there. And if we select this, we can see it's set for light source elevation. Let's switch this to 12 feet and it'll push itself up. We're going to move this. We need to unpin this so we can move this endpoint of this reference plane, which is really just for visual reference. It actually goes to infinity. I'm doing this so I can get a nice clean intersection for the light source. And what I can do now is I can give it a parameter for the height so that we can adjust it. So typically you'll go and create your align dimension. DI is the keyboard shortcut. I'll click out here and place it. That's a simple dimension, but if I select it, I can parameterize it by giving it a label. I'll click right here and I'll give it a label and I'll put it as lamp underscore height. I typically don't leave spaces just for the sake of simplicity and ease of visually seeing what the name of the family is. And it is a family parameter. We'll keep it as a type because that way when we load it into the project, if we use this lamp post family, say along the sidewalk, and we've got 10 of them along the sidewalk, if we adjust this on a type level, they'll all change. And we'll hit OK, and that height is done. Now, in regards to looking at the picture, let's take a look at initially the vertical structure itself. This one, we're very lucky. This is very, very simple in the sense of the design. And the logical thing to use would be to do the revolve command and make all of this base data, the vertical stem data, and then this top uh, receiving housing, if that's what you want to call it. So, looking at the picture, we want to make sure we understand like the height of where this is sitting, the height of where this is sitting, the height of this, the height of this, and the height of this. So we need a ton of reference planes to define those heights. So I'm going to type in RP, which is the keyboard shortcut for reference plane. And I'll put in, I don't know, say a 3-inch base. And unfortunately, the picture, I cannot really, I can scroll the wheel to see if I can get bigger, but it doesn't look like I can get any larger. So we're just kind of estimate the height. We're going to say 3 inches and then, I don't know, 2 inches and then maybe a foot and then rough it from there. Okay, so let's switch back to Revit. So there's 3, do one over here roughly at 2, we'll do one roughly at a foot. And this is all adjustable. So switching back to the picture, we've got a little one somewhere along here. And then we've got this top piece here. So I'll just put it somewhere around here. And it's kind of hard to see from the picture, but I think I'll just keep it a simple. And then, so that's getting all of the horizontal lines here. And then we got to take it all the way up to this top part here. So we'll create a reference plane up here. I don't know, roughly here is fine. And again, when you're creating the reference planes, try to keep them so they all line up. It just makes life easier for you down the road. And I'm gonna draw. I want that light source dead center of that housing. So what I'm doing is the horizontal planes for this. So let's drop that down a little bit to here, and then drop this down to, I don't know, here. Okay, so now we get a little bit more granular. This is at 3 feet, which is fine. This is at 3 inches and 2 inches, that's fine. And then we've got this, which is 1 inch in between, that's fine. And then this is at 6 inches. Let's go higher. Let's move this up by 3 inches. And then this is at 1 inch. Okay. Now, when we're doing the design of this, we have to ask whether this information here, here, here is adjustable, and here, if it's adjustable in height. We're going to make all of this fixed to make life easy. But you can parameterize everything, really, honestly. But for the sake of ease, I'm going to put in the dimension and lock these dimensions. That way, this doesn't change. And then a lot of times when you're modeling, depending on the scale that you have set initially for the family, your annotations may look a little large. So you may want to switch to something a little tighter. Let's do 1 inch. That's fine. And then up here, we need to dimension this as well. And we'll lock this, and we'll dimension this as well. And we'll lock this. And that upper picture, yeah, we'll keep that simple. There is like a little lip right there at the bottom, but I'm not going to bother with it for now. And then lastly, looking at this housing, let's initially put it at some reference plane height here. And I just want to measure from here to here. That's at 3 feet. That's a little too large. I'm guessing this is probably 1.5 feet at most. So let's take this at, let's do 9 inches. And then we'll take this and move this to 9 inches. And that way everything kind of holds, and that'll be our housing of the light source. Okay. Now, the middle obviously is nothing more than a vertical cylinder of whatever diameter. If we go to the reference plane level, we can go ahead and just create using our Boolean operations. And so in this case, we're going to be using extrusion for the main cylinder, but we'll use a lot of revolve for the main structure. So I'm going to do an extrusion, a circular one. And if we want to, we can parameterize this, but I have no idea how big this street lamp post is. I'm just kind of guessing at the sizes, but let's look at the vertical shaft part being, let's do 3.5 inches, just as a starting point. Now you can parameterize this, obviously. So if you select this and you hit this little temporary dimension icon to make this dimension permanent, we can, again, switch this to the right scale, and we can parameterize this so we can make the main structure diameter larger or smaller. It's up to you, okay? Again, we're going to keep it simple. So I'm going to keep it fixed for now. I'm just going to get rid of it, leave it alone. Actually, I'm going to parameterize that. No, I won't parameter. I'll leave it at that. We'll finish it. If we go back to the front elevation, this is what it looks like. So we need to move the cylinder up to where it needs to go, which is going to be to here, and lock it. And this one to here, and lock it. From a real world structural standpoint of how it's built, it's probably going all the way down to here at the very least. So I'm going to remove that and then align and lock it to here. Because a lot of times this base design thing is nothing more than a cap that's just placed on top. So we've got that. And then this will probably, the top part will probably go to here, actually, to this, uh, to, um, to this plane right there. So let's move that back up a little bit to here. So we're unconstrained from the previous and locked to this one. Now, when it comes to this design over here, the base, let's deal with this lower plate and the second plate that's on top. That can be nothing more than, again, either an extrusion or a revolve. If I do say an extrusion, and we go to the reference plane, we can create that here and extrude it. But since we create a reference planes here, it gives us that sense of vertical height. It doesn't give us diameter in the sense of the size. We know this is 3.5. So if I just want, for the sake of kind of visual understanding, I'll do a reference plane at say 6 inches. And I'll place this one here and then this one here. So now we can get an idea of if the base is only a foot wide, this is how much it is. And a foot's not that wide, actually. Let's go, instead of doing 6 inches, let's do reference plane at, say, 10 inches. There. And then the other base looks a little inset inside there, so let's go 8 inches. And if we go back to the top elevation, we can kind of get an idea of the size now. So I'm going to go in and create another extrusion, circular one, and draw it to there. And finish it. And then go to the front elevation, and again, move this to where we need to move it. So make sure the top goes to whatever plane you need. Make sure you move the bottom as well, so it aligns and locks to the correct plane. And then rinse and repeat for the inner one. So create extrusion, center to there, finish it, head back to the front elevation, and again, move this to where it needs to go, lock it, move this to where it needs to go, and lock it. Okay. This piece in the middle here is also kind of the same thing, but this time I'm going to do a revolve just so you have an idea of the difference. So we want that revolve to be coming around this part of the column, if you will, and it is much closer inside than compared to this. So it's let's do a reference plane. Instead of 8, let's do 5 inches, just so we get a visual cue. Okay. So we really want to create a profile that's along here that's going to be revolved around this vertical axis right here. So create a revolve, and typically I choose the axis line first, and then I choose boundary line, and then I can draw what I need. So in this case, I'm just going to create something like this. And if we look at this in 3D before I finish, you'll get an idea of what's going to happen. So this rectangle is going to get revolved around this pole. So when I hit the green check mark to finish the creation of the profile, it'll revolve it, and this is what it looks like. And it finishes the revolve command finishes. Now, also little things like you look really carefully, you kind of can't see some of these lines where the geometries are kind of intersecting each other. So you can use the join geometry command to join content. And that way it looks a little sharper and cleaner. Okay. Now, obviously, this is not like smoothed out from the picture because it's kind of hard to see. It's a really small picture and I can't zoom. But if I really wanted this, instead of being a simple rectangle, I can always change that profile. So if I select it and edit the revolve, I can change this profile design. Maybe I don't make it straight. Maybe I make it curved. So I'm going to delete that, use boundary line, and do a 3-point. Let's pick roughly here to here. And then we'll just take this and move this to there. And then we will trim the corner. TR is a keyboard shortcut, like that. And if we select it, you're going to see some lock and unlock functions for tangency between the line and the arc. Typically, you want to lock them in place so that they stay connected. And then because we already did that there, I'll just mirror this to this side. And then I'll delete this. Actually, I don't even need that. I'll just get rid of this. And if we finish it, there we go. Looking at it in 3D, this is it. So just like the lamp post down here, this looks like it's very squared off. That's squared off. That's kind of rounded. This base here looks like it has a larger diameter at the bottom than the top. So if we go to the front elevation, we kind of need a reference plane somewhere along here to do what's known as a blend, to go from here to say here. Yeah, so I will create a reference plane. Let's just do like, I don't know, an inch or so. A lot of times when you're building families, especially when you're just pulling off of a picture, it's really hard to get a sense of scale and size. But honestly, at the end of the day, when you're building families, you want to make sure you have all your measurements down. Sketch everything out by hand. Makes life easier. So I'm going to do a blend that goes at the base plate using this here as my visual indicator for the diameter, down to another cylinder at the top using this as my indicator. Now, before I do that, we have to make sure that we know what planes we're going to be using to go from bottom to top. If you notice, I created all these reference planes, but I didn't give them any names just because I was just kind of working quickly. You really should name them for the sake of use down the road, because you might need to refer back to them again when you're doing different Boolean operations. So in this case, I'm going to select that and call this base top RP. Oops, sorry. We're going to call that base bottom RP. I'm going to call this base top RP. This is just for when I do the blend, it's going to ask for two reference planes, this one and this one. So once I name them, I know where I'm going. So top versus bottom, okay? And then I accidentally selected and dragged it. So let's go back to the reference level. And we're going to go back to create. This time we're going to say blend. When you do the blend, it assumes you want to work with the base initially. And you need to set that plane. So I'm going to click set work plane and make sure it's the base, base bottom. And it will be a simple circle. And it will be the larger one. So we're going to click here. Then we're going to click edit top to do the top one. And we're going to set the plane to be the top plane that we set earlier, base top RP. Obviously, the naming convention of your planes is very, very important, because if you aren't really good at that, doing that, it gets kind of loopy and crazy. So if we take a look at this in 3D, we've got the top reference plane, we got the bottom reference planes, and the sketches for the profiles. Hit the green check mark, and it builds it. Now, when it builds it, it doesn't necessarily place them where they need to be as it does the extrusion. It's kind of purposely built like that. So if I push and pull this down to where I need it to go and lock it, I'll be okay. Same thing here. And lock it, and I'm okay. So there's the base. See that? So moving up to this top part here, that looks like it's just a little, I'll keep it simple. We'll do another revolve, and we'll just use this and this. So create revolve axis line, picking this boundary line, and we'll keep it simple. And finish. And look in 3D. See, there's a top. And again, use joint geometry if you want to make everything look kind of clean edges. we need to work on this top part here. So same kind of understanding. This time I'm going to do revolve because this is kind of a unique little shape here. And we know we have a lot of reference planes to work with to kind of create an interesting sketch, a revolve sketch. So I'm going to go and say create revolve axis line, picking you, boundary line. So now I'm going to kind of sketch a neat looking design. So I'll go here to here. Let me go back to the picture. Okay, and it's kind of curved out to about right there. So let's do a 3-point. So like, I don't know. I guess here is fine. And then we do another 3 curve here to here, like that. The top looks like it's got some kind of vertical. So we'll just do a straight line. I don't know, 1 inch should be enough. And then coming across to here and then down to here. And again, if we look in 3D, this is the goal, is to see this object get revolved and finish it. And there you go. Now you have the housing. Again, use joint geometry. And, you know, depending how fancy and complicated you want it to make, you can shell it out and put in a lamp and all this other, an actual bulb and all this stuff. But for the sake of, you know, today in this video, we're keeping it simple as we can. And then the top part is this, you know, really pretty looking, transparent glass looking type of shape. And again, um, it'll be a revolve. Now, because this is pretty big already, I think I'm going to make it higher here. So let's move this up to, say, I don't know, 1 foot 3 inches. I'm looking at it from the sense of proportions. So this is more and this is less. So we want, and we haven't done the horizontal lines for this pretty part here, but let's create a reference plane roughly up here and then roughly over here. And we've got 1, 2, 3. Yeah, we'll keep it like that. And then looking from the standpoint, that's 1, 3. Zoom in here. This is at 4. Let's make it 5 inches. This is at, oh, let's do that, 2 inches. Nice clean numbers. And obviously this is just kind of a rough end, but let's just wing it and make something interesting. So again, create, revolve, axis line, pick it, dead center, boundary line. Now, let's model this. Let's draw this. It's very, very curvy. So I'm going to do a 3-point curve. We're going to go to, say, roughly here. Roughly out to here. And that. And then coming to here. Oh, I don't like that curve. It's okay. Let's see how it looks. Yeah, let's do it. Let's initially do it like that. Oh no, that's too much. I don't like the way that looks. Doing somewhere in between. And then we've got a little top part. So let's go and, for now, we'll just, oops, sorry, do a line. And we'll run it across to here and here. Now, since this is going to be transparent and it's kind of like, it's just a glass cover, then what I will do is I'll make my profile like this. And I'll use pick line. And we'll do the, I don't know, 1/8 inch is more than thick enough. Oops. And we'll just do that instead. And then come over here and boundary line to here and 0. Okay, then we have to clean this up. Because when you're creating your profile sketch, when you're in sketch mode, you have to have nice clean lines, no gaps, no overlaps, no straight lines anywhere. And so this is going to be our shell, if you will, and it's going to be revolved. So let's finish this and let it revolve. And then obviously, since it needs to be transparent glass, we need to select it, and then we can click right here under by category for material, drill into the material dialog box, and just look for glass. We've got glass right there. Okay. And because it's set to shaded mode, it's like that. But if I switch to, say, hidden, it looks like that. If I switch to wireframe, it looks like that. So let's just leave it as shaded for now. And if we look carefully at this picture, the proportions wise, this is more vertical than what I modeled, but you kind of get the idea. Okay. When it's all said and done, you have to, obviously, you have to save your work on a regular basis, and you have to flex your geometry to ensure everything's working properly the way you want. Now, I created these reference planes just to kind of model this stuff, so I don't really need these for now. And I really don't need these anymore, so I'm going to get rid of them. You can always, put them back in, but these I do need because I want them locked so they stay that vertical height, because the only thing that's really going to flex in this is the height of this geometry. If we push and pull this up, it's not going to let us know that it's locked in position, see? So we're going to leave that the way it is. And we're going to test to make sure that we have this dimension is locked. We have this one that's locked, but we don't have a dimension from here to here. And we'll lock it as well. And I like to keep all of my stuff kind of lined up nicely. So if we've done it correctly, if we change the height of the lamp post, the design, because we parameterize that lamp height as 12 feet. If I say make this 15 feet and I hit OK, what happens? Does it pull up like it's supposed to? Yes. If I go down the road of changing this from 15 to, say, 25, does it go up like it's supposed to? Yes. If I go lower than what I initially put, say 6 feet, does it do what it needs to do? Yes. I mean, that looks like a really tiny short. But at the end of the day, that's what we want. So I'm going to say, let's put it at 25 for now, because street lampposts can be pretty tall depending on the street that you're working with. So now you're done. It looks okay. Look at it in 3D, verify everything looks okay. The last thing really is the light source itself. So if you select the light source, you can edit the light source definition, and you can tell it what shape it's emitting. In this case, it's either going to be a point or it's going to be a circle like this or like this. It wouldn't be square or linear line based. Light distribution can either be this or spherical or hemispherical spot or photometric web. So for what we're doing, these two will be just fine. And then lastly, going over here to the properties of the family you're building, you can set things like, let me move this over a bit. You can set it to be things like work plane based, always vertical, cut with voids when loaded, showing the light source, maintaining orientation, whether it's shared or not, and even room calculation point. So what we need to do, this is more than good enough. So I'm going to save it, close all the other views that I don't need. We'll start a new project based upon commercial is fine. We'll jump back to the lamppost and then we'll load it into the project and then we can place it. See? So we can place it however we need to place it. We can see all of them. It shows up nicely in 3D. We can shade it, looks good. Going back to the family, if you need to, um, you can select all of this geometry and give it material as well, right? So I can grab this and this and this. I'm using the control key, holding down the control key to select more than one geometry. Um, so I can select all of this, go into the material dialog box and give it some kind of material. Let's look up under aluminum and we'll just do generic aluminum. And then we'll save it, load it back into the project, overwrite what we have, and then look at it in 3D. See? So this family, like I said, is a very, very simple family to build because the nature of the design is simple. But if you were to go back and do other family, street lamp post families that it can be complicated like this one, it's the same premise. Build your vertical structure, build your housing and everything as a single family that's a host family. Then if you want to, you can build this housing and the light source as another family and nest it into this main housing family, and then copy it, rotate it and everything, and align and lock it where you need to be, and then give this a vertical height. So all of this and all of this will remain in the exact same height position because you'll lock it from here to here, and the only thing height-wise that will change is from here to here, or from whatever height here to here that you define. Other than that, that's how you build a street lamp post family in Revit. What I'll do is I'll finish the video, do some quick editing, throw it up on the YouTube channel, and then for the end user who is requesting it, I'll put a link copy of it in his comments or her comments. Other than that, thank you very much for watching.